This video is for chapter 11.2, part 1. We're going to go ahead and for 11.2, we're going to run a hypothesis test again in a confidence interval, but this time we're going to um, compare two populations in a match pair style. Um, in order to do that, again, what that means is you're comparing two groups that have been matched in some way, husband and wife, president with their opponent. Sometimes even you're looking at before and after results of the same person, and you're trying to see if there's a difference. And to run, you should have your 11.2 note sheets out, and then you can see that first page of how we actually run a hypothesis test with a population mean from matched pairs data. We again have to assume um, we can use these techniques provided that all of these are true, and these are again very similar or what we had before. What we're doing with matched pair data, we are basically doing what we did in chapter 10. We're just looking at the difference between the matched data. And so we run the step 1 for it is to write a hypothesis test. And the big difference you see here is the mean difference. The mean, the average of the differences of the matched data is equal to 0, or it's not, less than, or greater than. And so that's your step 1, writing your hypothesis test. We're going to do an example right now so we can see that. Of course, step 2, select the level of significance. Step 3, you're going to compute a test statistic where you use the p-value approach. And so, again, and we don't do this by hand. We use StatCrunch to do that. Since it's a mean, we will be using degrees of freedom again. And so n-1 will be used. And then we check to see again, is the p-value is less than alpha. We go ahead and reject the null hypothesis. So all the steps are here, just like before. So we're going to go ahead and then get started. One thing that we need to consider in a hypothesis test for matched pair data is the idea that all these procedures, things we do, we call them robust, which means that minor departures from normality, meaning if the data is not truly normal, we can still use these methods. One thing we got to be worried about is if there are outliers, then we shouldn't. The procedure shouldn't be used. But again, our data is not going to have outliers, or at least in these cases, there are examples. And so let's go ahead and do the first example. Get you an idea of what's happening. So you have your note sheet out. You go ahead and read that. So what we're going to end up doing is comparing 2 hotels in 10 cities. And check and see, do we have a difference in the mean prices between, not the average of each of the prices, but between cities? Is there a difference in prices? And so the mathematics that gets done is you actually find the differences between them. And then when you find the difference between, those cities, and I have one value that's off here, this is 100, actually subtract the differences. You add them up, and then you find the differences between them. What's the mean of these differences? And in this case, you would get 51.4. And then you get a standard deviation. If you did the math, I'm just telling you what it is right now, 8.3. You would end up with what we're going to be comparing is, in our hypothesis test here, right? What we're going to be comparing is something called the mean difference. And so that's what gets written in our hypothesis test. Is there a difference from city to city between those cities? And so what we have here is the test the claim that Hampton Inn is priced differently. So there's the keyword, that Hampton Inn is priced differently. And so what we're looking is that Hampton, which is our first one, does not equal La Quinta. And so that's going to be our claim. And so what hypothesis we write, you go back to, if you go back to the note sheet up on top, how they're written, this is what we have. These are our ways that we're going to do our null hypothesis. And so in this case, what we have is the null hypothesis says that the mean differences is equal to 0, and then the alternative in this case is the mean difference. Remember, that's mu is not equal to 0, that there is no difference. We're going to test this at the alpha 0.05 level. This turns out to be a two-tailed test. How do we go ahead and get those statistics? Right here, we go to StatCrunch. Stat, and in this case, we're doing t-stats for means to sample with summary. Sorry, this is, let's do this again. T-stats paired data. And if this is going to be done, paired data to sample, if it's going to be done, we need to enter in the data. So let's go do that. After the data is in, we go ahead and run the test. The data in from our note sheets there. We go ahead, run a t-stat paired. Column 1 is Hampton, column 2 is La Quinta. And then after you have those in, you have to do the test, and we're saying that it is equal to 0 and then not equal to 0. I mean, the difference is equal to 0. So the null hypothesis alternative is that there's a difference. Compute. When we compute it, you get your t-stat, and then you get a p-value. And so again, that number 5.27 is what we would put in there. P-value 0.0005. So we end up with a t-stat here, 5.27. Your p-value, I think, was 0.005, definitely smaller than alpha. We do the same thing. Decision. We reject h sub 0 since 0.005 is smaller than 0.5. What's our conclusion? There is sufficient evidence to support the claim. Support the claim that there is a difference in prices. That's it. And then, of course, we could also do a corresponding confidence interval as a hypothesis test. We would do a 95. You go back to where we were, and there you're going to find a confidence interval. Options, let's edit. And so instead of hypothesis test, do the confidence interval for this situation. It's going to find the mean of the differences, the way I was showing you here. So we get two values. You get 29.3 and 73.4. 29.3 and 73.4. 29.3 and 79.4. What do the results mean? We're going to reject h sub 0 since the confidence interval does not contain 0. So this is just an alternative way of writing a hypothesis test. We can use confidence intervals, and in this case, your point estimate would be the average of those two, and the margin of error is that difference. So what we discover here is that the point estimate is going to be right in between 54.35, and the margin of error is 25.35. And so what we're saying here is we're 95% confident that the mean difference between hotel prices is between $29 and $79. If we looked at all the hotels, like the population of hotels, it would be a difference. And that's what we got. That's the first example.